Hello everyone. Today we're going to be taking a look at the last section of Chapter 11 on geometric probability. And when some people hear the word probability, they cringe, but this is really not too difficult because we're just going to be finding a ratio of two areas. So we basically have to calculate two areas. One is the area of the event of interest, and the other is the total area for all events, and then we form that as a ratio, and that's our probability. Let's take a look at a few examples. Here it says a dart is thrown at the dartboard shown below. If the radius of the smallest circle is 1 centimeter and the width of each ring is 1 centimeter, what is the probability of hitting the bullseye? So our area of interest is this bullseye. So that's going to go in the numerator. So I need the area of this circle, and we know the area of a circle is pi r squared. So I'd have pi times 1 squared, which would just be 1 pi, or I could say pi. So this is the area of interest. This is the area of the bullseye. But we also need to know the total area of the dartboard. So the total area of the dartboard, we need to figure out the radius of this. And notice it said that the width of each ring is 1 centimeter. So this would be 1 centimeter, 1 centimeter, 1 centimeter, for a total of 3 centimeters for the radius of the entire dartboard. So the area of the entire dartboard would be pi times the radius squared, which would give us 9 pi for the area of the entire dartboard. So then we need to actually calculate the probability of the dart landing in the bullseye. And to do that, we take our area of interest, which is the area of the bullseye, and divide it by the total area. The total area of the dartboard being 9 pi. So notice here, the pi's would cancel, and we'd be left with just 1 in the numerator. So our final answer for this is 1/9. In other words, the area of this circle is 1/9 the area of the entire dartboard. Let's take a look at a second example. Here it says parachutists jump from an airplane and land in the rectangular field shown. What is the probability that a parachutist avoids the two trees represented by the circles in the diagram? And we have a slight assumption here that we're going to assume the person is unable to control the landing point. So they're going to land somewhere in this field. So our total area of interest, or I should say our total area of the field, is found by finding the area of the rectangle. So that would be 100 meters times 80 meters. So that total area would be 8,000 square meters. We also need to find the area of these two trees that we want the parachutist to avoid. So there's a tree here and a tree here. Notice that we're given the diameter of the tree and not the radius. So we need to actually calculate the radius for these. Here the radius would be 5, and here the radius would be 8. Next, I'm going to find the area of each of the trees. So for the one tree, the smaller one, it would be pi times the radius squared, or pi times 5 squared, which would give us 25 pi. And for the other tree, the area would be pi times radius squared, or pi times 8 squared, or 64 pi. So the total area of the trees would be 89 pi meters squared. So to figure out the probability of the parachutist landing on one of these trees, we need to take the area of interest, or in this case the area that they're trying to avoid, 89 pi, and divide it by our total area, which was 8,000. And these are both in square meters. It's important that the units are the same. Our units cancel, and then if we actually want to get a decimal approximation for this, we would have, we take 89 pi and divide it by 8,000. Let's see. Let's do that. 89 times about 3.14 and divide it by 8,000. We have about 0.039 or about 3.5%. So it's definitely more likely that they will not hit the trees than they would hit the trees. We'll be working more with this idea in class tomorrow.